What do we have here? A little bit of steam going on. It smells like turkey. Not really. Instead of using a heat gun, if you got something like this can be a whole lot more efficient. Let's take a look inside. What do we have for temperatures? 357. This is a 390. Let's do that one first. Alright, here's your generic X-Torq top end. This one here is probably in pretty good shape. It's probably one of my takeoffs. And this is for an original edition. This thing needs a home. Look at that. That's really nice. Right? Get these off the table. One of the things that I'm going to do is on my preferred X-Torq build, where I use an original edition top end on a good set of cases, but I blend it to the X-Torq carburetor. I'm going to start trying to put this top cover on a low top carb filter, because see how it kind of bows out in the back a little bit to accommodate the larger air filter that the 372s have. You got these larger filters here. Well, with a low top cover, the air filter kind of interferes, so I need to do something there. While somebody might want to use this case, that is not an acceptable scenario to me, where you can push a bearing in by hand and then push it out with your fingers like that. But I've seen a lot of 2010, 11, 12, 13, even into the 2014 X-Torqs that have that case beat out. Now the problem is that once that's done, you can't buy a case half to match up with one of these. You know, I mean, there's nothing wrong with these flywheel sides. You know, they're fine. But I highly recommend buying a case as a set. One of the things I've been doing is on my hobby saws where I want throttle response, the Highway 52mm pop-up top end, the lighter flywheel on, doesn't matter what set of cases. I got, like I said, I've got one on Chinese cases. And that makes for one snappy saw. And then I blend the X-Torq carburetor to that, and you get some RPMs out of it. Which is another thing. I think the 372s, even though the original editions are designed to run no load at like the 13.5, where the no load on the X-Torqs is around 13, the actual operating RPMs of the X-Torq is a little bit less by design. You see, the original editions have got a lot more transfer cross-sectional area. It's a little easier for them to run the higher RPMs. One of the modifications we do on this is gutting the filter holder and the intake, and basically gutting the port. You see that on our videos, to where now both sets of passages are flowing gas and air, and that effectively is adding a little bit more power and RPM capability to the X-Torq. Now, is it a good idea? I don't know. They run strong. You build one of these suckers right, an X-Torq runs strong. And since you can pull the caps, you can adjust the top of the transfers to pick up a little more cross-sectional area there to mitigate what you've done by dropping the cylinder. It can do it pretty easily. And I got to tell you, a built 372 X-Torq is one strong saw, and it's also a little bit easier to modify an X-Torq than it is an original edition, simply because with the original edition it's hard to get down inside there and modify the transfer ports. And I went through that a little bit before, where not only do you raise them, but you get an angle on the ceiling of the top of the transfer, so you mitigate the turbulence created by that square edge of the piston, which is now being exposed when you drop the cylinder. I went through that in the last video. But for the hot rod guys, the guys who like to tweak on saws, you know, as much as I like the original editions, I'll tell you what, it's a bit of a toss-up between the X-Torques and the original editions. I like the original editions because you can buy something like the highway top end and just slap it on there and have a very strong saw and don't have to spend a lot of money. And you can do it with tools from Lowe's without a lathe and, you know, a machine shop. And but the guys who've got the skills and the tools, you know, these X-Torques, they can be made to run really strong, no doubt. And it's really tough to beat a well-built X-Torq. It doesn't pay me to say that, it's just common sense. You got a bigger carburetor after you've gutted all that stuff, and you can adjust the transfers to pretty much anything you need. And you can do it fairly easily. You can raise the exhaust port and open things up and just get these things to flow like crazy. But you still have that big heavy piston. So while it's a good, you know, saw for cookie cuts and get-togethers, the world that I'm working in and the people who work the saws that I build, they're not interested in that at all. They're interested in having it run the same 2 and 3 years from now after it's been run every day as it does when they pick it up, you know, from my shop. They're looking for longevity. They're looking for reliability, not for the extra tenth of a second in a cookie cut. Completely different world. Another little side thing, one of the fads that was kind of kicked around online was using the bearing from the 576s, because they have the same outside diameter and they have the same inside diameter, but they're a little bit wider this way. And that's because they have an integral seal versus having the seal pressed into the case. They're also nylon cage bearings. Okay, I'm not going to go there. But to put one of these in the 372 creates a whole bunch of dimensional issues. So if you go and hog out the cases, I mean, I guess it's theoretically a person with a machine shop could do it. But my question to those who would think that way is why? Why go through the effort? You know, you can buy really, really good quality bearings for the 372, and you don't have to go through all that machine work to try to get a 576 bearing in there. It doesn't make any sense to me at all. So these are 576 bearings. They're nylon. They're a little thicker. I don't know if the camera will pick it up, but they're 15, 20 thousandths thicker. Oh yeah, I work on 576s pretty frequently as well. What's next? Handles. This came off my new FarmerTech XT, and we're going to get into that saw a little more. And I had some problems with it returning to idle, and while I can't feel any roughness on this handle when it's off the saw, for whatever reason, when it was on the saw, it just wouldn't let it go back to idle. I don't know if it was something the way the cable is, or maybe it was kinked. But, I mean, when it's sitting here all by itself, it doesn't look like that bad a piece. I mean, yeah, it's square and blocky and all that. But, you know, it's got some weight to it. Got some thickness, you know. I think it deserves a second chance. Now, I went and ordered a handle from FarmerTech Puzzle, and you get this one here, which is slightly different. Oh, let me pull it right out of its bag. Maybe I can show it a little bit better. Here it is. Here it's all in its glory. But if you look at it, you see like right there, it's more rounded. This one's more square. If you look very carefully, you see that that is more of a fillet. That's more of a radiused area in here that this one is. It feels better to me. And like I was saying before, one of your clues is when you look at the casting at this end, you can see how that's different. And also it's more radiused in here. I like this. I like these handles better than these. You see how that's chamfered in here? This one is not. This one's a lot easier to put on the saw than this one. So that's another thing I like about this particular handle design than the one that came on the XT. So, but anyway, it needs a job. You know, I'll give it a job. There's nothing intrinsically wrong with it. It's just as I pointed out with the different casting down there in the guard and more radiusing and the chamfer up in here and stuff like that. This one is a better handle to me. I like this one better. So that's another little side deal. He's off the table. But right, if you look at this, you notice how the other one I just showed you had the chamfer right here. This is an OEM. It has the same chamfer. This big old square thing does not. So it's little things like that. And look how much wider this is up here versus the OEM, which is radius like the other Farmer Tech handle I was just showing you. So the other Farmer Tech handle feels same down here. See the way the casting is versus this one. This was definitely different. This one is OEM, and the other Farmer Tech handle I just had in my hands is much closer to the OEM shape than this one, which is probably why I like that one better. Yeah, it's all jammed up, so I got a couple of these. To those people who say that never happened, look at that, 375 XP. Where a 375 was what they used to call an XPW. And the XPW was a 51.4 millimeter top end instead of the standard 50 millimeter top end. And we went through that as well as just one of the different permutations of original edition 372s. I happen to like that top end. You've seen it on my video, and that's what I have on my saw. And the two things I like to do with 372s is either the Highway 52 millimeter pop-up or the OEM 51.4 millimeter top end, and all of them I like to run a little bit lower RPM and make it torque versus rev, and that is completely counterintuitive to all the people online where it's all about, oh, I can go 14,000 RPM. I think that's so overrated. And the guys who run my saws, the ones that I build, they tend to agree. They'll say things like, oh, I got to rev that little hot rod saw, but I don't have to in this other saw, especially that Highway. That's a beast. All right, where do I go from here? I think the first thing I want to do is I'm going to shut the camera off and clear the table a little bit more and try to boil it down to some stuff that we're actually going to work on. More show and tell. To review. One of my favorite builds, and I used OEM crank inside the aftermarket cases. Of course, it has the Highway top end. That's aftermarket. This is OEM. It has an X-Torq carburetor blended to the original edition. You saw it in the video. It has an OEM pull start, aftermarket handle. I can't remember what that is. But this is a beast of a saw, and it has already made a lot of money for a fella, and it's survived full-time use, and I want to use it this fall because I like it. And I need to wear out these total bars, which don't work very well for felon, but they work very good for firewood because they're very, very hard. Those 4 rivet tips just don't survive if you do a lot of bore cutting, but the steel they have in the bar itself is really hard. Last a long time. And another little detail is you see how I have my muffler mod where I angle it up and out as compared to into the work. This is another point I like to make, is just drop a vector like that. That's where the exhaust is going, and as you get into the bigger wood, I'm not having my exhaust blow right into the wood. So I was babbling about my muffler when everything shut off. Lost my power. Here is a 372 that survived the test of time. It was a logger's saw, and he hires a bunch of Amish young fellows to run it, and it's been run like that for a long time. So as much as 372s may not have as durable a reputation as, say, a 390 or others, here's one that has survived. But it runs a little lean, you know. It picks up RPMs at idle. A little tough to get it to idle and stuff like that. So we're going to break it apart, and I'm going to try to salvage this one and do my typical build on this before it actually, you know, fails. One thing I want to point out is that big square handle. Remember I mentioned that it wasn't as easy to get on and off. It has the other aftermarket option. You got to take these and kind of fold them in here. And when that thing is not chamfered, it doesn't go in quite as easily. You see how that right there runs right into the case? I mean, yeah, you can jam it in, but it's not as easy as... See how that's chamfered? So you got a lot more room. It just sort of pops right in, just like that. And the reason why it's so easy is because you have that chamfer right there. I think that's a significant difference. So let's just start taking things apart here. I guess I hadn't gotten these things out of here just yet, so I need to get this stuff out of here. See this little grommet right there? I swear to God, I lose those things all the time. Always get some spares if you're working on 372s, of pieces like that. Another one is these. Both the sleeve and that little washer. Keep those around. And there's a little O-ring, and I guess it's still on the crank. Keep those around. Oh, another piece. Keep track of this little rubber hose right there. I cut that out of the fuel line. And this little rubber bumper right there. That rubber piece right there, the hold the carburetor. Things like that you got to kind of keep track of. Should be ready to come apart, right? The bearings, it's nice and smooth. So there's really nothing wrong with those bearings. So there's really no reason to change them. Okay? Because I want that bearing. You see it just dropped out? I don't know if you noticed, but I got it up a little bit more than 300 degrees this time. The bearing just fell right out of it. And again, the anvil that I use has just got to be the same diameter as that. And again, if you have the temperature up, it's just a matter of setting it in there. Maybe a little tap. But it shouldn't be an interference enough to matter. It should just drop right in if you have enough temperature. One of the differences you see on some of the other aftermarket cases like these, if you look at the top of where it stores the bar oil, there's no stiffening rib, where on the OEM cases there is. The reason that is that would be like a 371 case, like the first generation of the Husqvarna of that series, the 371s. And some of them didn't have that stiffening rib, and somewhere along the line they put that stiffening rib in. And that's one of the differences, okay, between the aftermarket and the OEMs. The current OEMs. Another difference between the aftermarket and OEM, as I had mentioned before, is the diameter of these locating pins. They're bigger. And another little anomaly is, if you look at these aftermarket cases, this locating pin here is solid. A screw will not go through it. This one here is hollow. A screw will. And of course you have to put the screw through there in order to get into that, see where the locating pin goes. So not only are they larger in diameter than the OEM case, one of them solid. Keep that in mind. Now I had found on these that the bar oil slot, this whole casting right here, was just a little bit different than stock. This was a little bit lower. It didn't really appear to matter that much on the G372. If you look carefully, you can see it. The distance between the top and here. On the aftermarket cases, it's 220. On the OEM, it is 190. So it's definitely a little bit different. So that slot for the bar oil is just a little bit different on the aftermarket, at least these aftermarket ones. Now, the cases that I found on the G372 XT had that in the right position, and I think it had a stiffening rib. But just a couple little things, little interesting things to consider. Now, so we've taken bearings out and we've put them back in, took them back out again, and I ran it to 300 degrees. The reason I went to 300 degrees was to make the temperature enough where the expansion differential between this material and the bearing material is enough the bearing just comes out easy. Now, if you have a chilled bearing and bring this up to 300 degrees, you can just set it right in with your finger. And then let it, just make sure you keep it where it's not going to fall right back out on you. So when the whole thing cools back down, it bites the bearing where it's supposed to be. But that's called heat differential, doing that. And that's the right way to do it. Now, whether you do a heat gun, a hot plate, which I'm going to do, I have one around somewhere, hot oil, I mean, in an oven, you can have a little toaster oven. How you get to that temperature doesn't matter. But getting that temperature is really the right thing to do. And the other thing is I'm assuming steel cage bearings. Very critical, because that nylon doesn't like the heat as much. So, yet another reason why I like using steel cage bearings on all my 372s is because when I get them warm like that, ain't going to bother them at all. Those bearings will be fine. I'd say any questions, but you're not here. Now, let's put the cases together. I didn't change these bearings on this set of cases because they were fine. I'm going to have to find a different crank because this aftermarket crank completely failed. Now, I want you to look at a couple things. Usually, if it failed because of like a lubrication issue, over revving, or something like that, you would see the color of that connecting rod go blue. There were a couple I had that were like just blue, that were straight gas jobs. But that never got hot. That never got hot. And there was plenty of oil inside the cases. There still is. There's a film of oil everywhere. That just outright failed, guys. I mean, that bearing just failed. It wasn't because of lubrication. It wasn't because of heat. It wasn't because of anything except for it was an inferior bearing. All right. So I am not a fan of these cranks. They can earn their way into my grace, but so far my experience has been 100% failure. Of course, as Bob says over and over, that is a sample of one. So what I'm going to do is I'm going to set a crank into those cases. Let me pick the worst one. Here, this one's a little gritty. That's the tightest. That's a good crank right there. Alright, this is the worst crank. Even though it's smooth, there's the most amount of twist and play. So this is an OEM crank that probably has a lot of time. One of the things I do with the 1184 is I glue the gaskets on. Let me tell you what. You know it when they're on there. Get that thing clean, clean, clean. Go to the other side. So I take carb cleaner or something like that and I go through and clean these dry. Make them as clean as I can. Make sure there's no oil left on these surfaces. Once I've got it at that point, make sure you have the locating pins in. And as I had mentioned before, on these aftermarket ones, you got to make sure you put the right locating pin in the right spot, because one's solid. Putting this together is pretty easy. Here's the gasket. See, I usually start with a PTO side. Let me do that. The reason is the PTO side is a little bit longer from centerline. So what happens is when you pull the crank through, the connecting rod will be trapped there, and that's a good thing. Pull the crank through. Either you use a Husqvarna tool or mine. It doesn't matter. They both work. Mine's really just a Husqvarna tool with a handle. So they work the same way. And then basically the idea here is to have a bushing that pushes on the cases like that. I mean, some people want you to push to the inner brace of the bearing. If you can, that's good. Knock yourself out. Sometimes you can't. And actually, on this one I can, so let me just do it. Oh no, I can't because it's got a seal. The seal is still in there. So since the seal is still on, I'm going to have to do it to the case. It doesn't matter. It'll work either way. So when you do this, make sure you have the connecting rod to where you can control it, right? So it doesn't get jammed up against the case by having the crank turn on you. That's a common issue that people have. And then basically you snug up here that nut, and then just take that nut with a big wrench and bring it in. That's it. Remember, that's a reverse thread. That comes right out of there. Now sometimes I'll put two bushings, so I step that nut a little further out, make it a little bit easier to work with. And now you have the one side pulled through, right? I've got the gasket material and everything all ready to go. Pull these out of here, because I have a little oil in there. And it's just the same thing. Notice how the crank has the connecting rod set up in there, so you don't have to worry about that now. And then pull it together the other side. Just basically set it like that. Gasket's already there, right? Get that nice and snug. And it's the same game. Basically, I just take that nut and pull this thing together and pay attention to the locating pins to make sure that they're actually going in the right hole, right? At some point, what I'll do is once I get like right about there, is I'll drop a couple of screws in. Now I won't tighten them. I'm just getting in there for, you know, helping with alignment. You know, where's my drill? Again, don't tighten them. Just get them into where they're helping align. And now just take it basically and run it home. Now sometimes it makes sense to put a little bit of oil right there so this crank doesn't turn. And I'm going to tell you another thing, is the guys who want you to put this bushing on the inner race, you can do that. But if that bearing isn't... Well, I ran out of memory with the other camera. So basically what I did was I just wound that down until it came to a stop. Every once in a while you hear a creak. If that bearing is not set all the way into the case, let's say that bearing is set in like that, and you've got your bushing where it's sitting on the inner race, you're not going to, you'll sit there and pull like crazy. You could have a chance of actually breaking off the tip of the crankshaft in that scenario. When you put the bearing in there, and you, of course you have enough heat, you got to make sure that bearing sits all the way back into the case, all the way to the back of the pocket. And one of the advantages of using this approach with a flange, let's say that bearing isn't exactly all the way back, it'll pull it back, you know? So once you got your crank pulled through both sides with these tools, of course the Husqvarna tool does the same thing. I think I've got a whole bunch of them in here. They do the same thing. These are crank jacks. I've got pretty much every one that Husqvarna ever made. Another reason why it's nice to have that handle the definition of win is when I can just take my fingers like that and just turn that crank like that. One thing I did not do, which I need to do, this is just a test case, and it doesn't matter I guess on this one, is those are already oily, but you set a little bit of oil in those seals before you pull the case together. That's a step I didn't articulate. You got to put a little bit of oil in both the bearings and in the seal before you do what I just did. So I set my crank jack on that. I bottomed it out, so it was the face of the crank jack is on the crank. I used a brass hammer and I held the case with my hand here, and I tapped on the end in until the crank was basically centered by eye. You can do it with feeler gauges if you want. Okay, but again, notice that it turns nice and free. See what I'm saying? So that, my friends, that's how I put the cases together. And I'm sorry my camera ran out of memory, but I've done it this way for quite some time, both with the 1184, but also remember to oil the seals and the bearings before you put the thing together. Sometimes I'll stack up two of these in order to get the wrench a little bit further away, especially on this side. If you stack up two bushings, now your wrench is out here instead of up against the case. So other than that, so I think I got enough for a video, and that's a lot of discussion on 372 cases according to me. Everyone has their own opinion. Seal drivers. I didn't mention seal drivers. Let me just do a quick addendum. What I do is I've got these seal drivers that when you set the seal in on the case with a crankshaft in there, you set that over, the crankshaft centers it, and when you tap it down, it pushes it in an extra 15 thousandths. But also Seeing it's being centered by the crank, that means it's being pushed in straight, right? So that's what I use for the PTO side. Sets on the crank. What you do is you set the seal down in there, set this over the crank and tap it. And on the flywheel side, you got to push it in a little bit there as well. And sometimes it's hard to get the sealant square. So I've got this tool right here, which sits on a crank jack, and that aligns the tool. And then when I tap it, it taps it to the same depth every time. And I machined it so it would do that. So I basically put the seal in, put this on a crank jack, which has been cut down so I can tap on it and then tap it. And that's how I put my seals in. So Husqvarna also has seal drivers. It's just I made my own, just like I made my own pullers. And you guys can get the Husqvarna shop tools from places like HL Supply. So they have their own drivers, right? Of course, they have their own crank jacks. And I have pretty much all of them. So anyway, talk to you later. Bye for now.